Hello students, welcome to the video class. Today let us learn about physical and chemical changes. Every day you come across many changes in your surroundings. These changes may involve one or more substance. For example, your mother may ask you to dissolve sugar in water to make a cold drink. Making a sugar solution is a change. In the same manner, setting curd from milk is a change. Sometimes milk becomes sour. Souring of milk is a change. Stretch rubber band also represents a change. Dear students, try to make a list of 10 changes that you observe in your daily life. In this chapter, we shall perform some activities and study the nature of these changes that we observe in daily life. Broadly, these changes are of two kinds, physical change and chemical change. Let us first of all understand what is meant by physical change. Let us perform a simple activity. Try to understand a simple activity. Cut a piece of paper in 4 squares. As you can observe here in this image, one piece of paper has been cut into 4 squares. Again, each square piece is further cut into 4 smaller square pieces. What do you observe here? Here, you can see that there is a change in the size of the paper. Big paper has been cut and made into smaller pieces. But there is no change in the property of paper. Let us perform one more activity and try to understand what is meant by physical change. Take some ice in a glass or plastic tumbler. Melt a small portion of ice by placing the tumbler in the sunlight. You have now a mixture of ice and water. You can see here in this image, we have got the mixture of ice and water. At this moment, if we keep this glass in a freezing mixture, that is ice plus common salt, by putting this in by putting some freezing mixture, if we keep back in the refrigerator, we can observe that water becomes solid ice once again. Here, through this activity, we have understood, and in our daily life also, we observe these type of change. Ice that melts to water. Water again on heating starts boiling and it will get converted to steam. In the same manner, if you cool this steam, again it will get liquefied and it will be converted into water. Again, on freezing water, we get back the ice. In this activity, we have observed that there was a change in the state. Solid to liquid, liquid again back to solid, solid to liquid and liquid to solid. Here in this image, you can see that ice is converted to water, water is converted to steam. Solid to liquid, liquid to gas. Here we have seen the change in the state of matter. Let us try to understand one more activity. Hold a used hacksaw blade with a pair of tongs. Keep the tip of the free end on flame of a stove or candle. Wait for a few minutes. What do you observe, students? You can see that the color of the blade changes to red. Again, after some time, if you cool it back, it regains its original color. Here, in this activity, we have observed the change in the color of the blade. In all the above activities just now what we have discussed, in this activity you have observed that there was a change in the size or shape. in the paper activity. Change in state, that is ice to water, water to steam, steam back to liquid, liquid to ice again. In the third activity, the recent activity, you have seen that there was a change in color. Properties such as shape, size, color and state of a substance are called its physical properties. A change in which a substance undergoes a change in its physical properties is called a physical change. A physical change is generally reversible. In such a change, no new substance is formed. In all the above activities, you have seen that there was no new substance formed. Only there was a change in size, state and color. Such a change is an example for physical change. Dear students, let us now learn and try to understand what is meant by chemical change. Look at this image here. A change with which you are quite familiar is rusting of iron. If you leave a piece of iron in the open for some time, it acquires a film of brownish substance, as you can see here. It is acquiring a brownish layer, brown colored powdery layer. This substance is called rust and the process is called rusting. Iron gates of parks or farmland, iron benches kept in lawns and gardens. Almost every iron article kept in the open gets rusted. At home, you must have seen shovels and spades getting rusted when exposed to the atmosphere for some time. In the kitchen, a wet iron pan, iron tawa, often gets rusted if left in that state for some time. So, rust is not iron. It is different from iron on which it gets deposited. Let us consider a few changes where new substances are formed. Just now we have looked at some of the examples. Now let us perform simple activities and try to understand this chemical change. Dear students, here in this activity, we need to take a small piece of thin strip of ribbon of magnesium, stripe of magnesium ribbon, clean its tip with sandpaper, bring the tip near a candle flame, as you can see here in this image. You can see that magnesium ribbon burns with a brilliant white light. When it is completely burnt, it leaves behind a powdery ash that is collected in a cup. Look at this image carefully and see to it that the ash doesn't look like magnesium ribbon. The ash is completely different when compared to magnesium ribbon. This change, what you observe here in this activity, can be represented by the help of equation. Here, magnesium ribbon is taken with the help of tongs. It is heated by using Bunsen burner or candle flame, and after burning, ash of magnesium oxide is collected. Let us learn what is happening with the help of this equation. Magnesium reacts with oxygen and burns, and it gives rise to magnesium oxide. So the ash that is collected in this cup is nothing but magnesium oxide. Here you can see that magnesium oxide is a new substance that is obtained. Now again, let us mix this magnesium oxide. This is the ash. Magnesium oxide is the ash that is collected after the activity, after burning magnesium. So when magnesium oxide is mixed with water, it gives again one more new substance. This new solution that is formed is nothing but magnesium hydroxide. Again you have got one more new substance. Dear students, here continuously with all these activities, continuously you are seeing that new substances are getting formed. First, magnesium reacted with oxygen and it gave rise to magnesium oxide, that is ash. Again, when you mix this ash with water, it gives rise to magnesium hydroxide. Here you have observed the formation of new substance. When this magnesium oxide that is collected in the test tube, you can test it with the litmus paper. You have seen this. When you add red litmus paper to this solution, it is turning blue. What does this indicate? Yeah. If red litmus turns blue, it indicates that the given solution is basic in nature. So, the magnesium hydroxide that is obtained is a basic solution, is a base. Dear students, let us perform one more activity to understand the chemical change. Here in this image you are seeing we have got the copper sulfate, that is also called as blue vitriol. We have taken copper sulfate crystals. Take about half a cup of water in a glass or beaker. Add few drops of dilute sulfuric acid to the solution. You should get a blue colored solution. Save a small amount of sample of the solution in a test tube or a small glass bottle. Drop a nail or a used shaving blade into the remaining solution. Wait for half an hour or so. Observe the color of the solution. Here you can see iron nail is put in the copper sulfate. Iron nail is dipped in copper sulfate solution. After 1 hour or half an hour or 1 hour, you can see there is a change in the color of the solution. Why is it so? Because there is a formation of new substance. If you observe the color of the solution, if you compare this with the sample that you have saved, you can see there is a drastic change in the color. Here it is blue and here it is green. This change that you are noticing here is due to the reaction between copper sulfate and iron. Iron reacts with copper sulfate and it gives rise to a new substance called ferrous sulfate and copper. Ferrous sulfate and copper are the new substance that we have got here. Iron sulfate is green in color and copper, which is deposited here on this iron nail or it forms a substratum, is brown in color. So here in this activity, we have learned that new substances are formed after this reaction. So this is again an example for chemical change. Let us perform one more simple and interesting activity and understand more about chemical change. Here you can see in this image, we have taken vinegar in a beaker or in a glass. Take vinegar in a glass or in a beaker or even test tube can do. Add a pinch of baking soda to it. So here baking soda is added to vinegar. Here as soon as you add, you can hear there is a hissing sound and also you can see bubbles of gas coming out. So if you pass this gas through freshly prepared lime water, so these bubbles are nothing but the gas, that is carbon dioxide formed here. If you pass this carbon dioxide to lime water, you can see that the lime water, which was colorless, it turns milky. You are seeing lot of changes here. Vinegar, which is also called as acetic acid, it reacts with baking soda, which is sodium hydrogen carbonate, and gives the new substance called carbon dioxide with other products. The reaction between carbon dioxide and lime water. Here, as you pass this carbon dioxide to lime water, carbon dioxide reacts with lime water, which is nothing but calcium hydroxide, and it gives rise to white precipitate, that is calcium carbonate and water. When carbon dioxide is passed through lime water, as you can see here, when this carbon dioxide is passed through lime water, calcium carbonate is formed. Calcium carbonate makes lime water milky. The turning of lime water into milky is a standard test of carbon dioxide. Here again in this image you can see the reaction lime water, calcium hydroxide. When carbon dioxide is passed to calcium hydroxide lime water, it gets new product. It converts into a new product called calcium carbonate and water. Since new products are formed here, this is an example for chemical change. Dear students, in the last 3 activities, you have seen that new substances were formed, whether it is burning of magnesium and formation of magnesium oxide, or dissolving magnesium oxide again into water and making it a base solution, or dissolving copper sulfate in water, or vinegar and acetic acid and passing carbon dioxide to lime water, that is vinegar and baking soda reaction. In all these cases, you have seen that new substances were formed. So all these are example for a chemical change. Now, since we have seen many activities and reactions, and we have tried to see with the help of images what a chemical change is, let us write and try to understand what is meant by chemical change. A change in which one or more new substances are formed is called a chemical change. A chemical change is also called a chemical reaction. Chemical changes are very important in our lives. All new substances are formed as a result of chemical changes. Whatever the new substances are getting formed, it is a result of a chemical change. In our daily life, in our physiology, digestion of food is an example for chemical change. In the same way, ripening of fruit, fermentation of grapes happen due to chemical change. The medicine that we eat is also the end product of a chain of chemical reactions. Useful new materials such as plastic, detergents are also produced by chemical reactions. Indeed, every material is discovered by studying chemical changes. Dear students, we have seen that one or more new substances are produced in a chemical change. In addition to new products, it may also accompany with the following changes. You may also observe that whenever a chemical reaction or a change is taking place, heat, light or any other radiations may be given or it may be absorbed. During a chemical change, heat may be given out or heat may be absorbed. Light may be given out or light may be absorbed. So this is again, heat and light is also produced as one of the product of a chemical change. Even sound may be produced. For example, when you are bursting crackers, you are seeing a change. It is a chemical change because lots of gases are given out. So during this change, you have observed sound. you might have listened the sound that is produced. So during busting of cracker, sound is produced. It is as a result of chemical change. In the same way, at your home in the kitchen, you might have seen this type of changes. For example, food items that is kept may get rotten and it may produce a foul smell. A change in smell may also take place, and it is also a result of chemical change. Chemical reactions may give off a smell or new odor. Generally, while food is getting rotten or rotten eggs. So these are all an example for chemical change. And in the same way, gases may also be formed during a chemical change. Here you can see in this image, in our daily life we observe bubbling, or fizzing, foaming. All these are a result of a chemical change. Dear students, now let us learn about a protective shield, ozone. Here, ozone, which type of change is it? Ozone is related to which type of change? Let us discuss about it now. We all know that ozone is a protective shield. You must have heard of ozone layer in our atmosphere. It protects us from harmful ultraviolet radiations that comes from the sun. We all know that ozone absorbs the radiations and breaks down to oxygen. Oxygen is different from ozone. Look at this image here. During the formation of ozone and for the breakdown of ozone, both ultraviolet radiations play a very important role. So if ozone is giving us protection from ultraviolet radiation, it is by breaking itself. Again, if ozone is getting formed, it is by absorbing this ultraviolet radiation. Both absorption, breaking down of ozone and formation of ozone is by absorbing these ultraviolet radiations. So we all know that ozone is created by extremely energetic UV radiations. Here you can see here in this image, ozone, O2 plus O, O3. It is a triatomic molecule. Here, when it absorbs this ultraviolet radiation, it breaks down to oxygen. Again, for formation also, it utilizes this oxygen. So, formation of ozone is also an example for chemical change, because once the ozone breaks, new products, oxygen and single oxygen, O2 plus O is new. These are the new products that is obtained there. So here breaking down of ozone is an example for chemical change. Here again one more example for chemical change which is related to ozone. Depletion of ozone. You can see when ultraviolet radiation falls on this CFC, chlorine atom detaches itself from chlorofluorocarbon and it splits the ozone molecule into O2 and O. So this is again an example for chemical change because we are getting new products here. Dear students, we all must have observed newly brought iron, a silver or copper article appears very shiny, but with passage of time they get dull. This is due to the layer of metal oxide that develops on their surface. Rusting of iron, silver jewelry getting tarnished, or copper articles getting covered by green layer. Metals react with atmospheric oxygen and produces metal oxide that are basic in nature because they react with water to form bases. In case of rusting of iron, the iron reacts with oxygen present in air and moisture and develops rust. Rust is nothing but hydrated iron oxide. Here iron is getting converted into hydrated iron oxide. You can see in this formula, in this equation, iron reacts with oxygen and water and it gives hydrated iron oxide, that is Fe2O3H2O, 2H2O. So this is called as rust. It is chemically a new product that is obtained. How should we prevent this rusting of iron? Prevention of rusting of iron can be done with different methods. The first method is galvanization. Galvanization is the method that is used to protect steel and iron articles from rusting by coating them with a thin layer of zinc. Here you can see in this image, the fence is actually made up of iron, but it is coated with zinc. So this coating of zinc prevents it from rusting, prevents the iron article from rusting. So such a type of iron fence is called as galvanized iron fence. Another one method is by alloying. We all know that homogeneous mixture of two or more metals or a metal and a non-metal is called an alloy. For instance, iron is used widely for different purposes, but it never used in pure state. It is due to the fact that pure iron is very soft and stretches in hot state. But mixing with small amount of carbon makes it strong and tough. Mixing nickel and chromium with iron gives stainless steel, which is hard and does not rust. So alloying is one more method of preventing rusting of iron. For preventing rusting, formation of rust can be prevented even by alloying. Musical instruments made of brass and bronze. Solder is also an alloy of lead and tin possessing low melting point and is used for welding electrical wires together. So all this is obtained by alloying. Dear students, now let us understand one more concept called crystallization. We all know that crystallization is a physical change. The process of deriving large crystals of pure substance from their solution is called as crystallization. It is a physical change. You might have seen crystals of salt are obtained by evaporation of seawater. When the seawater gets evaporated due to the heat of the sun, crystals of salt are obtained. So this process is called as crystallization. So crystallization is an example for physical change. Similarly, crystals of copper sulfate can be obtained by adding copper sulfate powder to the boiling solution of water and dilute sulfuric acid by putting few drops of dilute sulfuric acid. This mixture, when filtered and allowed to cool, produces crystals of copper sulfate. Thank you. Have a nice day.